Dear friends, today I am going to discuss about the steps to draw displacement diagram of the different types of all over motions. The previous class I discussed about the uniform velocity and the simple harmonic motion. Today I am going to discuss two more types, that is uniform acceleration retardation motion and cycloidal motion. For the uniform acceleration retardation motion, that is UARM, to draw the displacement diagram, as in the previous case, first you have to draw the rectangle, the height equal to the total height of the displacement of the follower, and length is equal to the length of the ascending angle, then the dwell, descending, and the dwell. Afterwards, divide the length of the ascending or the outstroke and the return stroke into 6 parts, that is preferably equal number of parts, equal number of even parts, that is preferably 6, that is ascending and descending. Then draw vertical lines from these points, that is 6 lines here and 6 line for outstroke and the 6 line for the return stroke. So afterwards, in the URM, uniform acceleration retardation, so in the URM, so in the first half it is acceleration, the second half it is retardation. Uniformly accelerate and uniformly retard. Okay, therefore it is known as uniform acceleration retardation motion. Then that is therefore the first 3 divisions acceleration and the next 3 division retardation. Here, for example, let's say in this the ascending or the outstroke, the 0, 1, 2, 3 are the 3 divisions. So in the vertical, the third division, divide the vertical line drawn from the point 3, that is from this. So this is the middle of the displacement, that is in this. Divide this into same number of equal parts. For example, if you divide this into 6 parts, then so here the vertical also should be divided into 6 parts. So if you divide this the length into 8 parts, then the vertical line should be divided into 8 parts. Therefore here it is, it should be divided into 6 parts. Then mark the points. So mark the points 1, 2, 3, 4, 5, 6. For example, here it is 30 millimeter. Therefore, the 5 millimeter each. The division 1, 2, 3, 4, 5, 6. Totally 6 divisions. Then, so after marking this, mark these points. Then join the lower 3 points to the lower left corner. That is to the point 0. That is 0, 1, 0, 2, and 0, 3. Then top 3 corners to the right corner, that is top right corner, that is to the point 6 here, that is 3 to 6, 4 to 6, and 5 to 6. Then similarly in the descending also, or the downward stroke also, the same division, the 9th division should be divided into 6 parts. Then top corner to the top 3 points and bottom corner to the bottom 3 points. Okay. Then afterwards, then the intersection of these points, that is 0, 1 line with the 1, 1 line, it is a point 1 intersection of this. Similarly 0, 2 and 2, 2, the point 2. Then 0, 3 and 3, 3, this is the point 3. Then 6, 4 and the 4, 4, it is a 4. Then 6, 5 and 5, 5, it is a 5. Similarly, same thing here also. The same thing, it is divided into, so it is mark these points, that is the intersection of these 2 lines, intersection of the lines, mark the points. Then that is the intersection of points, these lines and the vertical lines are the displacement, the height. Then join these points with a smooth curve, that is this here 0 to 1, 1 to 2, then 2 to 3, 3 to 4, 4 to 5, and 5 to 6. The similarity 6 to 7 like this descending. Okay. Therefore here, so you divide this, join these points with the smooth curve. This is actually the displacement curve. That is this line. This curve is a displacement, that is ascending, then dwell, descending, and once again dwell. It's about the uniform acceleration and retardation motion. Usually in the follower motion, for the low and moderate speed applications of the CAN, the simple harmonic motions are simple harmonic motion is preferred. It's about the uniform acceleration retardation motion. Next is cycloidal motion. The cycloidal motion, here cycloidal, as already it is explained, that is the cycloid is something but the trace or the, so when the circumference of the circle it rolls over the straight line, it will give the cycloid. But here also the same thing. Okay, here they, since so to draw a circle, therefore so this the total, the rectangle or the length of the displacement or the theta or the displacement the length of the displacement angle should be divided into 8 parts. So I will explain. Okay, here the first, the same thing, draw rectangle of a height equal to the height of the displacement, follower displacement, that is for example 30 millimeter. Here 30 millimeter is height, then length of the length is equal to the ascending or descending angle. For example, here only, as I consider it only for the ascending. Okay, so one for the only for the one displacement is either ascending or descending, so I consider it as ascending. Similarly, we can add 12, then descending, once again 12. And then divide the length of the rectangle into even number of parts. Here only for the cycloidal motion, it's better to divide it into 8 parts. For the uniform velocity, then the simple harmonic motion and the uniform acceleration retardation motion, divide the ascending or descending the length into 6 parts. Only for the cycloidal motion, divide it into 8 parts. Then mark the points and draw vertical lines from these points, these 8 points. So afterwards, draw the diagonal of the diagram, that is join 0 to 8. 0 to 8, draw diagonal diagram. Draw a circle with the center anywhere on the lower portion of the diagram, that is here. Just so below this, draw a circle. Okay, so on the lower portion of the diagonal, such that its circumference equal to the follower displacement, that is this circumference of this circle is equal to follower displacement, that is the follower displacement is nothing but the height, that is h equal to 2 into pi r. Circumference of the circle is 2 pi r. Okay, therefore h equal to 2 pi r, or radius of this circle equal to h by 2 pi. So for example, if it is 30 millimeter, means nearly the radius will get around 4.9 millimeter. This radius of the circle is 4.9 millimeter. That is just below the, extend this diagonal, then draw a circle of radius equal to h by 2 pi. It is nothing but so cycloid is nothing but so if you it is a point traced by the circumference of the circle which rolls on the straight line. Therefore, if you unwind this, then it will become the height. For example, that is circle 2 pi r is the nothing but the height. If you unwind this, then it will get the height of the displacement. Okay. That is, draw the circle. Okay, then divide the circle into same number of equal parts and number them. That is it is something but the, so this is the center point of the circle. Then divide the circle into same number of equal parts. For example, here it is divided into 8 parts. So here also it should be divided into 8 parts. That is nothing but the 45 degree each. That is 0, 1, 2, 3, 4, 5, 6, 7 and 8 and 0 in the same line. Let us divide this into 8 equal parts. So it is something 45 degree each. That is, it is 0 degree. Then here it is 45, 90, 135, 180, etc. like this. Totally 360 degree divided into 8 parts. And mark the points. So 1 to 7, 8, or 0 to 7 or 8. Then project the circle points to its vertical diameter. So here, for example, this is a circle. So it is a enlarged view. This is a circle. Okay, so here it is, circle is divided into 0, 1, 2, 3, 4, 5, 6, 7 and 8. Then so project the circle points to its vertical diameter, that is, it is nothing but here project this. So 1, and 3 here. Project this to vertical diameter. This is vertical diameter. Project is since it is divided into equal parts, therefore 1 and 3 draw a line or connect the points 1 and 3, then 0 and 4, then 7 and 5. That is projecting these points. That is 1 and 3 on this line, vertical projector projected to this vertical diameter. So here, then 2 here, then so 1 and 3, then 0 and 4, 5 and 7 and 6. Totally we'll get the 8 points here. 8 points here. So therefore, now the first project the circle points to its vertical diameter. So to this vertical diameter, project this. Then in a direction parallel to the diagonal of the diagram to the corresponding ordinates, and mark this intersection point. For example, like here first you projected to the vertical diameter, then in a direction parallel to the diagonal, that is already diagonal is drawn. Draw a line which is parallel to the diagonal, from this vertical projected points. For example, here, so 1 and 3 from this point. Here 1 and 3 from this point. Project this, draw a line parallel to this diagonal. 0, 8 is a diagonal. From this 1, 3, not from the circumference points 1, 2, 3, 4, etc. It should be so to project the points from the vertical projected lines in the diameter. That is 1 and 3. So to project these 1, 2, 3, 4, 5 points. That is the 2 in the diagonal only 2. Then 1 and 3 this point. Then 0 and 4 this point. Then 5 and 7 from this point, and 6 like this. Just draw parallel to the diagonal, this 0, 8. That is 2 here 1 and 3 project this, then 2 project this only 1 point, then this is 0, 8 and 4 project this, then 5 and 7, then this is a 6 like this. So afterwards, after projecting this, then mark the points. That is, for example, here 1, this line is 1. Here it is projected. It will intersect at the point 1, 1. So here in this line, vertical line 1, 1. Then the point 2 is projected here. Here this is a point 2. Point 2. Then 3 is projected. So here the same point 1 and 3. 3 is here. Then this is a 0, 4 and 8, 4, the projection of this point 4. Then projection of 5 and 7, here this line, this is 5, it intersect at 5, 5 and 7, 7, 7. Then 6, it is projected through this, here the point 6. Total will get 8 points, 0 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. That is, so all these are the parallel lines, the line drawn parallel to this, so it will intersect the vertical points. Now, so after this, join these points like with a smooth curve. This is cycloid curve, that is 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7 and 7 to 8. Join these points with a smooth curve to obtain the required displacement. This is a cycloidal curve. So most of the cases in the high speed applications, this cycloidal motion is preferred. That is the cam displacement with the cycloidal high speed applications. High speed engines they use the cycloidal motion, whereas a low and moderate speed simple harmonic is used, as well as the dynamic operations, that is a frequent change of operations. This cycloidal curve is preferred.